the fact that the Cent engine has very high-level opcodes, and there's a huge amount of Cent engine metadata that also needs to be present within the encrypted bytecode, so you can restore a lot of things. And decompilation usually completely recovers unobfuscated code, and there are just small problems with protected members and classes, so that you will end up with when you have a child class, you will sometimes end up with the same function in two classes when actually the function was inherited. But sometimes it's not possible to detect that it was inherited. Yeah, and obfuscated code is still easier to read than bytecode. And one place where I tried this was Kayako Live Response. This was one of the shareware products I was talking about. And with Kayako, it's a case that you have only two files within Kayako are encrypted. And the customer said, well, audit it anyway. It's just two functions. There will not be a security vulnerability in it. Actually, he was very wrong. There was a cross-site scripting vulnerability in it, and you see that which is marked red. It outputs the query string and a post variable called query string directly to the template, and usually this needs to be encoded for HTML. And it's not done here, and so it's an XNS vulnerability. And the nice thing about this, it's within the encrypted file. So even if you know about it, you cannot protect yourself against it, because you cannot change the source code. You need to contact Kayako, and if you are lucky, they will not sue you because you know about it. And so, because you normally don't, you are not allowed to decompile the source code in some countries, and so. You cannot fix it, they can fix it maybe, and yeah. Yeah? Yeah, you said I can decompile the code and patch it. Yeah, like I said, but actually this is illegal in many countries. You cannot just decompile the code, and if you can decompile the code, you of course can patch it. But this doesn't help the millions of users that you are using it. And you cannot fix it and just provide other users the fixed version. That's still, this is even more illegal. I didn't understand his question.
Why can't you provide a binary diff that anyone can apply? When did you become a lawyer?
Well, you can try that, but the problem is if you, the thing to get a binary patch, you would need to just buy the CentGuard and encrypt it again, and then you need to diff the files, and too much trouble. So maybe I can get to the last topic, which is bytecode, automatic bytecode analysis. The thing is, manual bytecode analysis is very time-consuming, and only if you are very crazy you want to read PHP bytecode. And normally you want to automate this stuff, and therefore you can try simple pattern scanning. Like normally many people that do source code audits start with a grep. You can do the same on bytecode, but it will give you much more information. And you can also do static and dynamic data flow analysis. I will show you some examples about pattern scanning. A question you usually have is how and where is user input handled in the application? It's a very complicated question, but this actually means in PHP, where is there a read, write, or is that access to the superglobals, which are get, post, cookie, request, file, server, and environment variables. At bytecode level, you can answer this question very easily. You just search for 3 different kinds of bytecode, bytecode opcodes, which are fetch R, fetch W, and fetch I. And when you find them, you just check the operand, and if it's a constant string and it's one of the superglobals, you know that there was a read, write, or is-set access on this thing. If you have source code, you can of course use grep for this, but then you will you have two problems. First, you will get all the accesses that are commented out, and secondly, you only get the information there is an access, but you don't get the information that is read, write, or is-set access. And most of the time, you only want the read access. Sometimes you also want the write access because you want to know if they change the arrays and try to sanitize them in some way, and so you know exactly where in the application they sanitized the input data. The next thing you can do with simple pattern scanning is to answer the question, what include or eval statements are really 100% secure? This is, of course, a question that will not help you in many ways, but at bytecode level, this only means you search for the include or eval bytecode, opcode, and you just check if the operand is a constant. When you have an include or an eval on a constant value, it can't be influenced by user input, and so these occurrence of includes or evals are always safe. Now you may maybe think this doesn't help you, but when you have a large PHP application and there are like 100,000 includes, then have fun grabbing through them and just look for yourself if it's actually a constant or not. And by just checking this simple thing, you can eliminate a lot of false positives. Yeah, but actually when you do want to understand more complicated things, you need data flow analysis. And I will just provide a very simple example of a backward data flow analysis that just searches for hotspots, which are dangerous send engine opcodes or functions, and then it traces backwards through the operands or parameters and checks if this is actually safe or could be safe or it's unsafe. For this, I have a very simple PHP function that consists of a simple if condition, and one time it includes a constant string and one time it includes a string that could be influenced by user input, depending on the input to the function. When you compile this, you will end up with this bytecode. When you look at the bytecode, you already see that the opcodes are obviously very, very high level, so actually you can recreate the source code from this in your head, if you're crazy. So, okay, let's start. I said we are searching for hotspots, so we search for the include or eval comment, and we find it here. What we do is we check the operand. The operand is a constant string, so we know this one is safe. We don't care. So the next thing is we search for the next hotspot, which is there. We have an include on the temporary variable 6, and now we need to scan backwards where this variable was written to. Because we have the code flow information, we know that there's only one possible place where we can go. This is the line before. And we see there's a write access to temporary variable 6, and it uses compiled variable 1 and concatenates a constant string. We know the constant string is safe, so we need to know if the compiled variable 1 also safe. So we are now searching for write access to a compiled variable 1. We go backward again, and we end up in an include statement that doesn't write to our variables, so we don't care. But now, due to the code flow information, we know there are two possible previous lines. So we first go to the right, and we see there's a write access to our to our compiled variable 1, and it writes a constant string in there. We know a constant string is safe, so we ignore it. We just cut the branch there and go to the other side. On the other side, we have a jump opcode. Jump code doesn't write anywhere, so we don't care. The next thing is an assign. We see there's a temporary variable 2 that is assigned to the compiled variable 1. So now we need to find out what is actually temporary variable 2. So again, we go one line backward, and we see there's an array dimension on an array that is stored in temporary variable 1, and the key action, this is stored in temporary variable 2. So now we know we don't know what temporary variable 1 is, so we need to find out what this is. So we go backward again 1 line, and there we see that it's actually the get array. We know the get array is user input, we consider it unsafe, and so we know that there's one code path at least that results in an unsafe include, and we can terminate here and say this function is unsafe. It doesn't matter what parameters the function uses, they're always unsafe. Of course, you can continue this, and if there are more hotspots, but right now there's only one. No, there's no hotspot anymore, and you don't care. Of course, this is a very, very simple example. It gets far more complicated when you have function calls, because then you need to trace all the parameters of the functions, and not only the result operand that gets written to. And you also have the problem that when you have function parameters that are passed by reference, that are also possible write accesses to your variables. So you also need to check if one of the parameters is actually the thing you are searching for. Gesundheit. Yeah, and this all looks very, very complicated, but when I experimented around with this, I was first implementing only a very small subset of the opcodes. You can see all the opcodes below. These are very, very few ones, but they help you a lot to just eliminate a lot of false positives when you're searching for include or require or evil statements that are unsafe. So these are just the opcodes that push variables of values to the stack, to the function stack. These are the opcodes that call functions. This is the include or evil opcode. Of course, you need to know it when you want to search include statements. It's a concat operator, which is used to concatenate strings. And last but not least, it's the fetch constant opcode. Usually, you see a lot of PHP scripts that use include constant concatenated with something else. And to understand that, you need to fetch constant opcode. And actually, I tried this very simple thing on one of the PHP include vulnerabilities posted to Milworm. And this example program had a very many includes and requires. And normally you would have to go through this manually. And I just tried my simple code that only understands these few opcodes. And it was able to find exactly what was reported in this Milworm exploit. So it was two cases where get was directly used in an include statement, and so I could reproduce exactly the thing reported to Milworm with this simple code. So if you are interested in this, next month you can download the ByteKit and you can play around with this. Any questions?
Yes. Hello?
Yeah, where?
There is an open source compiler called Roadsend. Actually, it's a different implementation of PHP. Do you know that? And do you know if these methods fit to this too?
I never looked at Roadsend because I don't know anyone who's actually using it to protect his PHP code. Most of the people are either using IronCube or SendGuardian. And in most cases, they actually have bought both products, and you can either download its IronCube encoded or SendGuard encoded. But Roadsend is not used so much.